right, today we're going to talk about reviewing sine and cosine graphs. So recall, if you have y equals a sine bx plus d or cosine, then remember we talked about a being the amplitude. And remember that the amplitude is always a positive, has to be positive because it's a distance. So if your a value is negative, you would have to take the absolute value of that. Then we have our midline, which is that d value. So y equals d would be the midline. And then the period. Recall that we talked about this equation, b times the period always is equal to 2 pi. So we said then that the period was equal to 2 pi over b. And then we have to know how to find the key point, which I always denote as kp. So that's the period, and we divide the period in 4 equal parts. The period divided by 4. So let's go ahead and look at the first one. When we are graphing this, we're going to make sure that we identify all the key features in the graph at least 2 cycles, so we'll do 3. So for this one, let's go ahead and look here with our a value. This would be our b, and this is our d value. So that means that the amplitude is equal to 3. My midline is at y equals -4. Since my b value is 2, from there I can find the period. So the period is equal to 2 pi divided by b. So in this case, 2 pi divided by 2, which is equal to pi. Then remember, we have to split that into 4 equal parts. So the key points are equal to the period, which is pi, and divide that into 4 equal parts. So when we are graphing this, remember that we always want to have all of our key points on our graph. So don't skip them. That's something that I'm looking for. So I'm going to write them at the top, and then I'll reduce them as I go below. So this would be 1 pi over 4. And the key points, remember, tell us how much to go from one key point to the next. So 1 pi over 4 plus another pi over 4 is 2 pi over 4. If I add another pi over 4, that would be 3 pi over 4. This would be 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. But you always want to reduce those as well. So this is 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4 doesn't reduce, then this would be pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. And so we also going to do the negative cycle as well. So negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. So for this graph, then my y-axis scale, I'm just going to count by 1. So this would be 2, 4, 6, -2, -4, -6. I always like to graph my midline first. So when we are graphing your midline, remember it's not really on the graph, but I'm just going to put a dotted line so that we know our graph should oscillate back and forth between this line. So this is at -4. So I'm just going to put my midline here. Again, that's just so that we know that our graph goes back and forth between this. So it should look like a wave, if we recall from last year. So now we have to remember that on our unit circle, when we had our cosine values, remember cosine is the x, and x, when we start here, is equal to 1. Then it goes to 0, -1, 0, and back to 1. So cosine, remember, doesn't start on the y-axis on the midline. It starts above or below. And how do you know if it starts above or below? You look at your amplitude. If it has a reflection, below. If it doesn't, it's above. So that means that this is going to start at the maximum on the y-axis because it's cosine. So cosine starts at a maximum. If it was a negative in front, it would be minimum on the y-axis. So here we are going to go from on the y-axis from the midline. Our amplitude is 3, so we're going to count up 1, 2, 3. Then we have to go back to the midline. Then from the midline, we're going to count down 1, 2, 3, back to the midline, and then at pi would be at -1. So this is our first cycle. Could you plug these values in and use your unit circle? Sure. So if I actually plugged in y is equal to 3 times the cosine of 2 times pi over 2 minus 4. 2 times pi over 2 is equal to pi. So you're really doing 3 times the cosine of pi minus 4. What is the cosine of pi? We know the cosine of pi is -1. So this is -3 minus 4, which is where we get -7. So you could do that, but it's going to take you a lot longer than just knowing it starts at a maximum. But because we are changing the amplitude, it's not going to be 1, it would be 3. So this would be 3, -3, and 0. And then we don't start there because we're changing where the midline is. We're going down from that. So another way you can think about this as well is find your max and mins. So if you know your midline is at -4, to find your max and min, you add the amplitude. So your maximum is going to be equal to -4 plus 3, which would be equal to -1. And your minimum value is -4 minus 3, which is -7. That's another way you can figure out those values. So now I'm going to continue to graph. So this is one cycle, and these values are going to repeat. So the next one is going to be at 5 pi over 4 at the midline, 3 pi over 2 at -7, and then 7 pi over 4 at the midline, and at 2 pi, it's going to be back at -1. And then if I do the opposite direction, I would just go in reverse. So if I did my cycle in reverse, it would go this way. So now I have graphed 3 cycles because from here to here is 1 period. So the period, of course, remember we said was equal to pi. And that's how we graph our cosine graph. The next one we're going to graph is going to be a sine graph. So here we're looking at this function. We're going to identify all our key features as well. So this is my, of course, A, this is my B, and this is my D. So my amplitude, remember, is the absolute value of that A value. So in this case, my amplitude is equal to 2. My midline is going to be equal to 3, or sorry, y equals 3, I should say. And then my B value is 1/4. So to find the new period, the period is going to be equal to 2 pi divided by B, which is 1/4. So that means we have 2 pi, we keep change flip, times 4 over 1, or 8 pi for the new period. Then my key points, we take the period and divide it into 4 equal parts. So 8 pi divided by 4 is equal to 2 pi. And because this is a sine graph, we know that sine starts on the midline, on the y-axis. So it's going to start on the midline. And then we also note that our A value, since it was negative, means it's going to have a reflection over the x-axis. So instead of going up, it's going to go down. And then we can also, like we did in the last one, so this time let's go ahead and find our max and min values first. So in this case, we know that the maximum is going to be equal to your midline, which is 3, plus your amplitude, which is 5. And your minimum value is going to be your maximum minus that amplitude of 2, which is equal to 1. So we know our max is at 5 and our minimum is going to be at 1. And then on my graph, because my key points are 2 pi, that's what I'm going to count by. So this would be 2 pi, actually just write down here. So 2 pi, 4 pi, 6, 8 pi, 10 pi, 12 pi, 14 pi, and 16 pi, of course, and then negative direction as well. And then my amplitude, again, you just count by 1 on the y-axis. So this would just be 1, or -2, -4, -6. All right. So we said that the midline is at 3. And then, so if this is my midline, then I know because this is a sine graph, sine starts on the y-axis on the midline. And then we know that since we start there, so we're going to put the dot right here. And then from there, because it's a reflection, normally sine goes up. So if you think about your unit circle values all the way around, sine, if we start here at 0, the sine of 0 is, of course, going to be the y coordinate. So the sine of 0 is equal to 0. The sine of pi over 2 is 1, 0, -1, 0. So normally we go up to 1, but because of the reflection, we're going to go down the amplitude. So at 2 pi, we're going to go down 2, then back to the midline, up 2, back to the midline. So this right here is my first wavelength of sine. And that would be, again, the first cycle. So this is 2 pi for the period. Or not 2 pi, sorry. 8 pi is the new period. Then if I want to draw another cycle, I just repeat those values. So this would then be 2, down 2, back to the midline, up 2, back to the midline. So that gives me another wavelength, and then same thing going in this direction here. All right, and something I didn't do on the last graph, but we can add in. So I can also find the domain and range. The domain of a sine or cosine function is always all real numbers, so -infinity to infinity. And the range uses, of course, the max and mins. So the range on this one, we said the maximum, as we can see, is -1, and the minimum is -7. So -7 to -1. And then down here, the range, we have the maximum we said was 5 and the minimum 1, so 1 to 5. And again, something I'm going to be looking for when you graph these is always making sure you're writing out those key points, so make sure that you include those. On graph number 3, we're going to do the same thing. So again, for this one, your A, B, D, the amplitude is equal to 5. The midline is at y equals -1. Your B value is pi over 2, which means that the period is 2 pi divided by pi over 2, which is 2 pi times 2 over pi. So your pi's cancel out to leave you with 4. So your key points are equal to the period divided into 4 equal parts, or 1. So that's kind of nice. So 1, 2, 3, 4, 5, 6, 7, 8. Same thing in the negative direction. And then we want to find our max and our min. So the maximum is going to be the midline, which is -1 plus the amplitude. So this would give me 4. And the minimum is always the midline minus the amplitude. So this would give me -6. So then on my graph, let's go ahead and do the y-axis scale. So 2, 4, 6. And then -2, -4, -6. So on my graph, we have our midline at -1. And so now from there, this is sine. So again, it starts on the midline. So start on midline. And this time, because there's no reflection, we don't go down first, but we're going to go up 5 from the midline. So up 1, 2, 3, 4, 5, which is at 4, which is why we have that maximum value at 4. And then at 2, we have back to the midline. 3 is going to be the minimum, which is -6, or you can count down 1, 2, 3, 4, 5, and see, oh yeah, it's at -6, back to the midline. So this would be my first wavelength of my graph, and then I'm just going to repeat those values for another wavelength, and then same thing in the negative direction. So that gives me 3 cycles shown as a graph. And then the domain, of course, is all real numbers, and the range in this case would be from -6 to 4. All right, let's do one more graph. So for this next graph, again, same thing, identify your A, your B, and your D variables. So the amplitude, of course, if it's not written, is just 1. And then your midline is, in this case, at y equals 2. The B value for this one is pi over 8. And then your period would be 2 pi divided by pi over 8. So when you do keep change flip, the pi's cancel out to leave you with 8 times 2, which is 16. That's nice because then the key points are going to be 16 divided by 4, which is just 4. So this would be 4, 8, 12, 16, 20, 24, 28, and 32. And then I'm going to change my y-axis scale so it's not too close to my x-axis key points. I'm going to make this 1 and this 2 and this 3 and 4. You don't always have to go by 1 on the scale. If you want to, you can. Doesn't matter. So now we have our midline at 2. And again, this is cosine, so it starts at the maximum, and it's going up because the cosine is not a negative in front. And so I don't think we did any, we didn't have another. If we had a negative cosine or negative a value, then we would go down instead of up, or start down instead of up. So in this case, we have an amplitude of 1. So the maximum, if it helps you to find that first, so the maximum we know is going to be the midline plus the amplitude, which is 3, and the minimum is going to be the midline minus the amplitude, which is 1. So we're going to start up at 3, or you can just even count from the midline up up 1, which is 3, back to the midline, down 1, back to the midline, and then up 1. So this would be 1 cycle. Just remember I did my scale on the y-axis by skipping every other one. And then same thing. So that would be 2 cycles and 3. And then if we were to find the domain, always going to be all real numbers for sine or cosine. The range in this case comes from our max and our min, so 1, 2, 3. Next part is being able to write the equation of the graph that we are given. So to write the equation from the graph, we have to find our A value, our B value, and our D value. So that's what we're looking for. And then we have to figure out, is this sine or cosine? So in order to do this, you first always want to identify your maximum and your minimum on your graph. So we can see that the maximum is equal to, the scale is going by 1, so this would be at 2, and the minimum is equal to, looks like -6. So that means then if you want to find the midline's the middle. How do you find the middle of something? You add the values together, divide by 2. So the midline, you take your maximum and you add it to your minimum and divide that by 2. So in this case, you have 2 plus -6 divided by 2. So 2 plus -6 divided by 2 means my midline is at y equals negative. So y equals what? -2. And then I'm going to draw it on my graph. So that's my midline. Now that I have that, I can count from my graph up 1, 2, 3, 4, because remember this is your amplitude. So I know my amplitude is equal to 4 by counting on the graph, or you can do the maximum minus the minimum divided by 2. Either way, it doesn't matter. So if I did the maximum minus the minimum divided by 2, that would be 8 divided by 2, which is 4. Or again, you can count on your graph, whatever works for you. Now that I have my A value, I have my D value. Now I need to figure out what one wavelength is. So one wavelength has 5 key points in one cycle. And remember the key points, what are those? They are the maximums, the minimums, and the where the graph crosses the midline or the intercepts if it's on the x-axis. So on my graph, here it crosses the midline, so that's a key point. Here we have maximum, that's a key point. Midline key point, minimum key point, but that's 1, 2, 3, 4. I need one more to make a full wavelength. And so when I look at this graph, this is starting on the midline. So because it starts on the midline on the y-axis, this tells me it's a sine graph. And so I don't have enough to go in that direction, but I can then count from here all the way to here to figure out the period is going to be equal to 8 pi. Once I know the period's 8 pi, then I can find the b value, because remember we said that the period is equal to 2 pi over b. So if we multiply b times the period equals 2 pi, you can also find the fact that your b value is equal to 2 pi over the period. So we're using that equation now. So in this case, we have 2 pi divided by 8 pi, which is 1/4. So that is my b value. So now I just need to plug it into the equation. So remember, we have y equals a, we're using sine, so times the sine of bx plus d. So if I use function notation, f of x is equal to, my graph goes up for the sine and not down, so I don't need a reflection. So this would be 4 times the sine of 1/4, we said was the b value, times x, and then we're going down 2 for the midline. So this would give me one particular equation for this graph. There are other equations, but we have to know how to do phase shifts left and right first. So we'll talk about those after we do our phase shifts. Now, when I look at this next graph here, I'm going to do the same thing. So I need to find the maximum and the minimum value first. So the maximum is equal to 10, and the minimum value that we have is equal to, looks like 4. So that means then the midline, which is the average, is going to be equal to the maximum plus the minimum divided by 2, which of course is 7. So 5, 6, 7 would be right here in my graph. So that is our midline. That means then the amplitude, I can count on my graph from the midline up 1, 2, 3, and the midline down 1, 2, 3. So now I know my amplitude is equal to 3. For the period, this is not starting on the y-axis and on the midline, it's starting below, so that tells me this is going to be cosine. And so if I count my 5 key points, remember that's where it has a max, min, and crosses midline. So this is 1, 2, 3, 4, 5. So from a minimum to minimum or maximum to maximum, that's your key point. You could always just do half the period and then double it. So if you wanted to do a minimum to a maximum, you could, like on this graph, I could have gone from here to here and then figured out that that's 4 pi, because you have 2 pi and 2 pi, and then 4 pi times 2 is 8 pi, so whatever works for you. So this is going from 0 to here, so that scale on the x-axis is going by ones, so that means this is at 12. So the period is equal to 12. To find the b value, we take 2 pi divided by the period, so 2 pi divided by 12 means our b value is pi over 6. So now I have all the information I need to write the equation, because we have y equals a times the cosine of bx plus d. So we have our a, b, and our d. You have to remember that because it's starting down, we do need a reflection. So if I write this using function notation, f of x is equal to, our a value is the amplitude, so we're going to say -3 because it starts down. So it's reflected. And then we have the cosine of our b, which is pi over 6 times x plus our d value. And our d value is equal to our midline, and our midline is at 7. So that would give me my equation. And then we have the last part. It says find the exact value of sine of pi over 6 and cosine of pi over 4. That's just using your unit circle. So on our unit circle, sine of pi over 6 is 1/2 minus the cosine of pi over 4, which is roots 2 over 2. Those are both in quadrant 1. They have a common denominator, so this would be equal to 1 minus roots 2 over 2. Looking at the next one, the tangent of 3 pi over 4. 3 pi over 4, of course, is in quadrant 2. 5 pi over 3 is in quadrant 4, so this is quadrant 2 and quadrant 4. Remember, when you're doing this, try not to use your circle. Try to think about your unit circle without using it. So tangent is sine over cosine at 3 pi over 4. Remember, that's the same root 2 over 2 divided by root 2 over 2. And when we are in quadrant 2, your cosine is negative, so that means this is going to be -1. And then cosine of 5 pi over 3 is the x-coordinate in quadrant 4. So again, remember that means you are down here. For 3 pi over 4, we were up here. So then the cosine means we have -1/2. So this is times 1/2. So then -1 times 1/2 is just equal to -1/2. Then the next one we have is 2 times the sine of 7 pi over 4 plus 3 times the secant of pi. So 7 pi over 4 is quadrant 4. So remember that is down here. And sine is the y-coordinate, so it's negative. So we have 2 times negative roots 2 over 2 plus 3 times the secant of pi. So pi, remember, is over here. Secant is reciprocal for the cosine, so 1 over the cosine of pi is what we are looking at here. So that means that if the secant is at pi, we want 1 over the cosine of that, or so then this would be, let's see, so then that would give us cosine of pi is the x-coordinate, so that's -1, 0. So this would be 1 over -1, which is equal to -1. And so then here, the 2 over 2 is going to cancel. So then this would give us negative roots 2 minus 3, and those cannot be combined, so that would be my solution. So just again for this part right here, so if cosine theta is 1 over secant theta, then if you were to cross multiply and solve, the secant of theta is 1 over the cosine of theta. I just wanted to point that out. Then looking at question 10, this one we have the cosecant of pi over 3. So really we're doing 3 times 1 over the sine, because the reciprocal of our cosecant sine of pi over 3 minus 5. And then you can use our properties right here. If you have the cotangent, it's odd, so you could take the negative out and make this +5 if you want, or you can leave that as a negative. It doesn't really matter, it's just a preference. So then cotangent, remember, is cosine over sine. So we would have the cosine of -7 pi over 6 divided by the sine of -7 pi over 6. And then I would want to figure out, well, where is -7 pi over 6? So to find -7 pi over 6, you can add 2 pi to that. So -7 pi over 6 plus 2 pi, get a common denominator by multiplying this by 6 over 6. So -7 pi over 6 plus 12 pi over 6, which gives me 5 pi over 6. So that's what it's coterminal with. Where is 5 pi over 6? It's right here in my unit circle. So then let's go ahead and do this side first. So we have -5, and then that tells me then the 5 pi over 6 for the cosine again is equal to negative, and this would be root 3 over 2 divided by the sine of 5 pi over 6 is going to be +1/2. And then we have 3 times the sine of pi over 3. So pi over 3, remember, is here in my unit circle at the top. The sine is the y-coordinate. So the y-coordinate would be equal to root 3 over 2. So this is 1 over root 3 over 2. So now we have to simplify this. So we have 3 times, if we flip this, this would be 2 over root 3 minus, and then over here we have a negative times a negative, so that's actually going to become plus because of these two negatives. but we can deal with that later if we want. So minus 5, and then this would be negative root 3 over 2, keep, change, flip, and then times 2 over 1. So these cancel out to leave us with negative root 3. And then here we have 3 times 2, which is 6 over root 3. We want to rationalize that, so this becomes root 3 over root 3. So when we do that, we get 6 root 3 over 3, which is just equal to 2 root 3. It's a lot of work. And then we have minus 5 negative times negative root 3 would be plus 5 root 3. So 2 root 3 plus 5 root 3. These are like terms. So remember, because they have the same radical with the same index, you can add the coefficients in front together. So this gives us 7 root 3. Another thing you could have done up here is if you have negative 7 pi over 6 for the cotangent, you can use that negative angle identity. So you could have said that that was equal to positive 5 times the cotangent of 7 pi over 6, and then you could have done it that way. Or sorry, cosine, not cosine, cotangent, because cotangent is an odd function. But I also like to remember my tangents and cotangents on the unit circle. So if you know those, that makes it even better, because then you don't have to worry about doing sine over cosine. But again, it's just what works for you. So that is all for our review of graphing sine and cosine, and then using your unit circle values.